We will start our lecture by giving the definitions of paths and cycles. These definitions according to your textbook, adapted textbook by Rosen. And if you would like to read about graph theories on other textbook, just be careful and read the definitions. There might be some minor changes. For example, in your textbook, the definition for path is not exactly the same definition for path in other textbooks. So what are the definitions for paths and cycles? We will start with paths. Now, when we say a path is basically an alternating sequence of adjacent vertices between two vertices V and W. If this is the source and this is the destination, so how to go over the graph by alternating vertices from the source to destination. So if you are visiting n edges, so if you are counting the edges from V to W, then the number of vertices, adjacent vertices, will be equal to n plus 1. Now, when you visit alternating vertices, here you don't have any restrictions. You can visit the same vertex more than once, and also you can visit the same edge more than once. So it is allowed to have repeated edges, and it is allowed to have repeated vertices. Now, a simple path, it is a path between two vertices, but there is a restriction that it is not allowed to have repeated vertices. Now, for a closed path is a path, but when we say it is closed, if it starts and ends at the same vertices. And again, you are allowed to have repeated edges, you are allowed to have repeated vertices. Now, for a cycle, it should be closed path, but you are not allowed to have repeated edges. Finally, simple cycle. It is a cycle, that means no repeated edges, but you are also not allowed to have repeated vertices. To summarize the definitions, then we have a table. So here, path, simple path, closed path, cycle, and simple cycle. And here, whether edges are allowed to be repeated, vertices are allowed to be repeated, and whether it starts and ends at the same point. Now, for path, it's a free speech. You are allowed to have repeated edges, you are allowed to have repeated vertices, and you are also allowed to start and comes back to the same point. Now, for simple path. For simple path, the definition says that you are not allowed to have repeated vertices. And in any path, if you are not allowed to have repeated vertices, automatically the edges will not be repeated. But the reverse or the reverse is not correct. That means if you have a path, you don't have repeated edges, not necessarily the vertices are not repeated. Now, for a closed path, we say closed path, it should start and end at the same point. And again, like path, you are allowed to have repeated edges and you are allowed to have repeated vertices. Now we come to cycle. And the definition says that a cycle is a closed path, but with no repeated edges. And if you don't allow repeated edges, probably you have repeated vertices. And again, if I come back to simple path, if we don't have repeated vertices, then automatically we will not have repeated edges. But if we don't have repeated edges, not necessarily we don't have repeated vertices. So it is allowed. And to be closed, then the first and last one should be the same. Now, finally, simple cycle. It should be a cycle, so no repeated edges. At the same time, no repeated vertices except the first and last one because it is a cycle. Here are some examples on paths, and let us go over the first one. It starts from C, this is the path. It starts from V1 and ends at V0. So let us go over these alternating vertices. V1 goes to V2, goes to V3, goes to V4, come back to V2, then you come back again to V1, and then you go to 0. So you have repeated edges as well as repeated vertices. Now, simple path. Since you have repeated vertices, then it is not simple. Is it closed? It is not closed because the first vertex is not the same as the last vertex. Now, is it a cycle? Since it has repeated edges, then it is not a cycle. Is it simple? Since it is not a cycle, then it is not simple. Remember, for a simple cycle, it should be a cycle. Now let's go for the second path. Now you are starting V2, V3, V4. So V2, V3, V4, V5, and coming back to V2. Is it simple path? Definitely no. Why? Because it has repeated vertices, the first one and the last one. Is it a closed path? Yes. Is it a cycle? Yes. Is it a simple cycle? Also yes. Because why it's a cycle? Because it does not have repeated edges. And why it's a simple cycle? Because it does not have repeated vertices. Now for the third one, we start with V4, we go to V2, V3, V4 again. So let's go V4, V2, V3, V4, V5, V2, and then again V4. So we have repeated vertices. So it's not a simple path because we have repeated vertices. See, this is 1, this is 2, so these are repeated. And is it a close? It is closed because the first vertex and the last vertex, V4 and V4, are the same. Is it a cycle? It is not a cycle because it has repeated edges. And since it is not a cycle, then it is definitely not simple cycle. We continue our definitions with some notes. A path with no repeated vertices has no repeated edges. So this is a result. No repeated vertices, no repeated edges. But from right to left is not necessarily true. A path with no repeated edges, which is called in some textbook a trail, not necessarily has no repeated vertices. Now we will talk about connectivity. We have to make a difference between adjacent and connected. When two vertices, they have edge between them, they are connected. At the same time, they are adjacent. But what is exactly the definition for connectivity between two vertices? Two vertices, V and W, are connected if and only if there is a path between them. So it's not necessarily they are adjacent. Now we will talk about graph connectivity. Now here we are talking about path, and here we will talk about a graph. So when a graph is connected if between any two vertices in the graph, these vertices are connected. There is a path between them. So if there is a path between any two vertices in the graph, then we say the graph is connected.